yours.
So let's start to share my screen.
Yeah, Philip, are you recording?
Yes.
Yeah, good.
Okay, I'm going to start to share my screen now.
Yeah.
Guys, let me know if you already seen my screen.
Yeah, we see it.
Okay, guys, welcome to coming for this attending. As Thomas said, I wanted to do a very good introduction on this amazing tool from Google. It's a BigQuery. And instead of just show a slide for everyone, I wanted to do more interactive stuff, like doing in real time for people see the action of this BigQuery. Even when we query a very massive amount of data, you see the response is quite fast. And that's what we're going to talk right now. I'm going to start with a little bit of technical stuff, which is going to show right now. Google start using develop with they done on their side, of course, which we call Dremel, which is amazing engineer for creating a very, very large amount of data. This engine itself is being used from Google since 2018 for internal proposal. Most all the engine in Google did all the research, include the search on web itself based on this engine, which they call Dremel. And that engine plus the Colossus, which we're going to talk right a little bit later on, is not open source. It's something which they keep a secret about. But in 2012, they opened this for the public, and people start using this amazing tool to query SQL over a large amount of data. I wanted to talk a little bit technical about what a BigQuery is itself. First of all, is a SQL query over big data. This is amazing because when we work with the big data, normally we do some tools like descriptive map reduce or something like that to query a database. And Google came with that solution to just use a very simple syntax, is SQL syntax, and they query a massive amount of data. This stack was done from Google, and the functionality of that is, and the stack is done by this Dremel engineer, and plus what Google called the Colossus, which is not a Google file storage, it's something more. It's a next stage of the Google file store. And this stuff, they, as I said, they keep it very, very secret itself about. And not only you query over a large amount of data, it's very easy, but when you use some language to program for extract big queries like Java or Python or whatever, sometimes you have to compile, debug, upload the stuff, and then do again all this stuff. So now you have the amount of data and you can just run some query over it is very amazing. The second, the other stuff I like to point to is the speed itself. There is this Dremel query was created to work in parallel. So you can parallelize SQL in a lot of machines, thousands of machines. And the good thing is, let's say you got one database with, an example, with 100 megabytes on your tables, and it takes you 3 seconds to run the query. If you increase it by 1,000 times, let's say now you have a 100 gigabyte, it may take only 5 seconds to run, and not the same amount proposed by the time we start. So this is very amazing. Other thing is based on cloud. You cannot run BigQuery outside of the Google project. I'll come to something later on. But as stored in the cloud, of course, you got all the replications done by the cloud, the geographic distinction locations, you got the security itself. But of course, always convene to backup all your data if you are running for a company. But instead, also it's very secure everything, you have to do that. All the flows with the goals from BigQuery to your, however you like it, to the client or whoever, all the data is being transferred, encrypted. It is very secure stuff. There is a few ways you can create your data or insert data in BigQuery. You can stream data, you can direct upload, we're going to do one example today, and you can do from Google Cloud as well. It is a structured database. It's very similar to relational database because it's based on collection of table and is very, very tied to schema. But it's not a traditional database system. Sometimes it looks like a NoSQL, sometimes it looks like a relational. We're going to talk about that. You cannot use a query to do something like an alter table, drop a table, update a table. So that is mostly more used for data warehouse, but not for replacement of relational database or things like that. It's a distributed cloud computer, and of course, it's a cloud data warehouse. Very fault tolerance, geographic distribution, automatic backups. As I said, it's running parallel. So many people started to say now it looks like analytics as a service. Other good thing I have to talk about is this global data namespace. Everything you create on BigQuery, you can also share with the people all over the world. So you can share your queries, you can let the people start to use your queries depending on however they live in the global. And it's up to you how you can secure and how you can leave the access. But you can transfer your query even for HTTP for people running. You have a web GUI, you got HTTP, as I said, you can do that. And then another good feature which is being developed is because it's asynchronous mechanism. When you run traditional database and for some reason, for network fault, for some reason you lost a connection, something goes wrong. All these relational databases are synchronous, so you have to restart the query all over again. And this is not a very good stuff if you are doing this on massive data. So that is another good feature where big data does, is asynchronous. They just started from the pool where we stopped it, for some reason they break down, and they carry on doing in parallel after that point. As I said, BigQuery, sometimes they look like a relational database, but it's not. Sometimes they look like a NoSQL, but it's not as well, and it's not based on map reduce. BigQuery is based on, as I said, it's Colossus, which is purchased from Google. It's a kind of a successor of the Google file system. And there are some similarity with this BigQuery in the other competitors or the other company who develop. And they mention here because sometimes it's nice to compare stuff. Like it's very similar to Cloudera Impala, Amazon Redshift, but Amazon Redshift uses a fork for Postgre, but it's similar factor, Facebook Presto. And this Dremel is the most similar stuff you find in the price is about the Apache incubator project, which is called Drill. So if people wanted to see or to go for the white paper to see how this stuff is more developed, you not find anything about the Dremel, but you can see about the Drill, and it's very similar. We have a good understanding about it. What BigQuery is, first of all, is an enterprise data warehouse. It's meant to be a warehouse. That's why I say it's not good for change the database. Sometimes if you need to change your table, you have to delete everything and then restart everything again. So it's very strong to keep your data as it is. That's why it's enterprise stuff. It's a SQL query, which you query under your data. And also you can support two types of SQL, the latest and the standard one. And also it's fully managed. You don't need to create a server, you don't need to deploy, you don't need to create an instance, but it has to be living on Google project. And you can access to web GUI, you can access to REST, API, client, or third tool as well.
Okay, Gilson, first question.
Yes, yes,
okay.
sure.
1 minute and that's it, okay? No longer.
Okay.
Because we have, I know you have a lot of slides. So the first question is, can you compare it, the BigQuery to a data warehouse on Oracle, 19C or Exadata?
Roughly speaking, you can. But as I said to you, it's a different process when this was developed. Even when I put the similar ones I found there, that one that I mentioned there is the most similar stuff I found so far to Google Cloud. You can do that, but not in very, very 100% similarities.
Okay, thank you. That's it for.
As I said, it is a schema detection. I don't like this tool myself. I will explain why, but it is a schema detection. It's loaded over extreme data. And let's say when you wanted to predict the schema of the stuff, normally big data does is they select 100 of the rows from your source and try to predict what is the data you got for each column. And then they create a column for you. I prefer to instruct the column myself. I'm going to explain why later on. It can be interactive, like you can run the default mode, you can run the query straight ahead, or you can create a match, you can create a view. And you also, when you create your table, you can also allow partition. This is done by Google, it's not for you. It's automatically done in case you need to do it. From this point, I think I gave a good introduction about what is it, if people wanted to do some more questions, because from now on, I wanted to do everything in practical. So everybody has any question about it so far?
Yeah, good. We see them. Google Cloud Platform.
Yeah, but as I mentioned, you have to, let's say, if you wanted to run some of these examples I showed today, there's two ways you have to do that. You can either create a Google Cloud account for you, which you can create the 1 year free trial and use your credit card to create it, or you can just Google for Sandbox. It's very similar way to create the Google account, but you don't need to put your credit card. There's some limit, of course, on the account, which is, if I'm still sure, you can run about 1 terabyte monthly, which is enough, pretty more than you need to for testing. But BigQuery has to be live on Google Cloud, okay? Should I start doing some presentation, or people want to know something more technical about? Guys, you are with me? Can you hear me?
Yeah, we can.
Okay. Okay.
We
So
have one question.
Yes, sure.
What is the data volume in this example?
I'm going to use quite a few different data sets. I think the most heavy I got is about almost 300 gigabytes. Some is very small, but I'm going to talk about the public data sets and how you connect these data sets, and we're going to not use only one. We're going to share different ones, different feelings, things like that. As I said, no more than the biggest one we're going to run here is about almost 300 giga.
Okay, thanks.
Okay, but there's a massive amount of data set in the market which you can do. When do you come to your project, guys? Very easily. When you create an account or however you do, you probably will be on this screen like here. And you can either create your BigQuery by looking around here, go type in the menu BigQuery, or just look around. And when you see BigQuery, you just pin, and after you pin it, it's going to appear at the top of it here. I just want to mention one thing as I open my menu. I remember BigQuery is very different than Bigtable. Some people confuse these two stuff, these two different applications on the cloud. Bigtable is much more like a Hadoop ecosystem, which run on MapReduce, Hadoop, all this stuff. BigQuery is completely different. It's not related. Okay. And then when you click BigQuery, you'll be coming to this screen. And you probably don't have anything on the left side, which I've got here. This, in my left side, there are some small, there are some data sets which I have already here. And how do you do this, find this public data set for run your test or whatever? How do you create the data set? Let's start talking about these public data sets. First, you can Google for a public data set, of course, but I think, in my opinion, the easiest way to find out is just come here to add data, and when you click in this button, you see explore public data sets. And when you click over here, you see the list of data sets. You just select which one you are interested in. And after you see the screen, you can say view data sets. When you click in this view, they drive you back to your BigQuery. And it's going to show for you, like for me here, I got already set on this side, but if not, it will appear on the left side of your screen. The only thing which I would like to mention, when you query some stuff and like you select some public data set or whatever, it doesn't show here next time you run the BigQuery. To do so, you just click on the BigQuery, going to appear the first time you try to get. For me here you see unpin, but if you never pin before, it's going to show pin the project. Once you pin there, you appear this pin in front of that, and this all the time you connect it to your BigQuery, your data is there, okay? I like to start talking about something important now. How do you know how much I will pay for the BigQuery? Because when you create something on the server, on the Google, like you create your data set, you don't pay for this data set. You only pay for the query itself. So how do you pay for that? And for me, the easiest way to find out how do I pay for that is when you create any kind of queries, you see on the right side, if the query is okay, you see this right at the green ticket, and you see this query will process in some amount of data. If you get this data, for this one, it's very small, like 20 megabytes. But if you copy this data and go to your, let's say, if you go to Google, I'm going to shut down here because the screen which appears there is showing. If you come into Google and just say, Google charge you €5 for 1 terabyte. So in that case, I got 20 megabytes. I have to convert this to terabyte. Just type this on Google, you'll see more or less how much it is converting here. And if you come here again and type this times 5, you're going to see the amount you're going to pay. For that query in particular, basically nothing. Let's do something else here. Let's query something more, let's say, now you see it's almost 30 gigabytes. Again, if I wanted to run this query and to see the price, I can get this. Go to Google, convert this to terabyte, get this value and multiply by 5. And you see that's going to be almost 15 cents for that query. The other thing I like to talk to you guys, which is very important. Everything if you wanted to know anything about this query itself, I'm going to talk right now this stuff. If you just point your mouse and press Control on your keyboard, you see they highlight the change column. If you click over there, they bring you tons of information of the table you are using about the data set. You see the scheme itself, whatever field it is. You see some detail about this stuff, how big it is, how you produce the table name, things like that. And also, it's very good, you can preview this data. So if you wanted to preview something, you never need to run any stuff over there. You can just check for this information and you find something which is related to. It is very important, you know, BigQuery is it is a column-based program that I say sometimes similar to NoSQL. It's not a whole-based program. If you see, if I limit this, let's say run this query, limit it to 1000. As you see, it's still the same amount to process, 29.4 gigabyte. If I reduce this by 100, it's still the same. If I want one only row, I'll pay the same amount for that query because it's based on column, not based on row. So if you, instead of query whole everything, that's why if you limit this for some column itself, you see how drastic they change the amount which they will going to charge you. So in BigQuery, it's much be safe to be checking very safe what you need to get the data from and by column, because if you just select everything, you're going to pay much more for that stuff. Okay.
Sorry, one more thing. Not sure if, sorry, Gilson, not sure
yes.
if everyone noticed. On the middle, you have the green text. It's showing the query proceed how many data. So
yes, yes.
If you can mark it.
Exactly.
Okay.
Yeah, and you repart it over here. Okay. And also, you see if you make any kind of a mistake itself. Let's see. And you see there is some error. And when you see this red stuff with the exclamation mark, you can open the validator and see what they give you a hint, what the mistake it is. In that case, they say, I do not recognize the title column. And they also suggest something very good for you. Did you mean title? So it's very easy to debug itself and know, okay, that's the wrong stuff, and now it's fine. Okay, it's very good tool for use as well.
Yeah.
Any question about that? How they charge you, everything like that? Let me explain something else before I go. Very important stuff. When you open, you see your screen here, you see this more stuff over here. There's two things you can find it there. First is the format stuff, which give you the shortcut for your machine, like your operation system. If you format your query, automatically they change however you type it to a nice format itself. And the second thing, the more important, is query settings. When you run this the first time, make sure you open this. And the most important stuff is here, the cache, preferable cache results. You see over here in my screen, on where I put my mouse over. And here as well, you can find you change it from legacy SQL or standard one, which I recommend to use only standard one. And this cache stuff. What that cache stuff is? When you run some big query, and what the tool does, they create for you a temporary table for that result. And from this result, from this temporary table, Google normally keep for 24 hours per user per project. That means if you run again this query over this period of time, you will not pay anything for that. They run from the cache and not from the query itself. If you do any change in your data set on your query, then of course they can do again everything to be charged. Is that clear to everyone?
Yeah, I think so. We have two more questions.
Yeah, sure.
Can you query dynamic data or only static data sets?
Only static data sets? No, in the end of the presentation, I'm going to interact with external data sets, like Postgre, for instance, which can be dynamic or something like that.
Okay, and how BigQuery handles just JSON files?
Handle some files.
JSON.
Yeah. I'm going to talk about that in a minute or so. But also, when you run some query as well, let's run that one. It doesn't hurt to run that. It's almost, you see, how long it's going to take it. Okay, it's 600 megabytes and it takes me for. If you come to here, as you can see, you got a result set over here. And in your result set, you also have some kind of information about the query, about the execution time of the query, if you want to be more precise, how long it will take is, how long they shift is. They took about 1.12 gigabytes on the table to run. It took 16 seconds to run on this amount. And also you can see, you can save the result as a JSON if you like to. And from there, you can just export your data. And you can export your data in different formats or either save the results. The next stuff I'm going to talk is how to update some file inside the Google BigQuery. I don't know if that answered the question, but if you got something also, please let me know.
We have one. Can you train machine learning models with BigQuery?
Yes, you can do that, but it's a little bit more different process. You could stream that, like use Kafka, for instance, and then use it from there with machine learning or things like that. Or just get this result outside, like if you use like HTTP for get the result and then pass it through machine learning. From this screen itself here, from the editor, not possible. But of course, you can stream the data and then as a stream, you can send it to everywhere.
Okay, and is BigQuery similar to Hive?
No, that is different stuff. That's what I talked about. If you come into Bigtable, it is. Bigtable uses Hive and Hadoop, all this stuff. And the underneath program about that is more hash table and what they call MapReduce. It's different process for querying databases or big data itself. BigQuery doesn't run in the same way. It's completely different. So it does Hive or things like that. It has as well a metadata, which I'm going to talk later on as well. It's been stored, but it's not based on Hive. It's only based on this, what we call Colossus and the Driven. Okay, any more questions?
I don't see anything.
Okay.
Yeah, let's move forward.
Okay. I'm going to say, let's say you can, how do I create a database itself, a data set? If you have your project, you can only create, as I said, inside of the Google project. You cannot get run queries or create a data set outside of the project. Let's say I come here, this is my project stuff. I come here and you see, create a data set. Okay. You can give any name for the data set itself. Let's say it could be names. And that's it. You can create a data set. And you see data set has been created. And if you open here, you see name is there. There's nothing there yet, but the data is there. So next time, I can transfer data there by stream, as I said. I can transfer data there by storage or by file, like JSON or however. You just need to come in here and say create table. From here, you can say I can upload the file instead of an empty table. I can upload the file. I browse the file and I got a lot of file here which is a comma separated. It doesn't matter if CSV or it's text or however, there's quite a different format to run. Let's run one of these, just open. And as soon as I open here, you can change this for CSV because it's a comma separated in my project itself. There is a tool field which is not so relevant, but there is R. The table name, you can have a give a name for that. Let's say again, names doesn't matter. You have it to relate it to one project, of course, and each one data set, which is all there for you. If you come to a CSV, you can come into the more advanced option, and from here you see something like you'll be a comma separate delimiter, or can be other different stuff like tabs, however, you customize it. And you also, if you needed to skip a number of rows, like if you have a head in your row, you can skip the first row. If you don't have it, you don't need to skip anything. And you can predict a schema straight from here. As I said to you, when they predict a schema, they will not give you a good name. They're going to give you like a F0 underscore, F1 underscore, things like that. In my opinion, the best thing to do is you can edit your schema, which is very easy to do it. You can just add this text for I got a 3 field in that text. The first one is I'm going to call this table name. It's type of string. It's just a comma separated. It can be one line only or 18 lines, no problem. String and count as integer. You see, if you need to partition the table, you can partition here. In that case, I don't need it to. But after done that, I can create my table. If everything's well, so the table is already created for you. And now you got a table over there. So if you check now, I got the table over here. And when you click on the table itself from the data set, you see on the editor something like a query table. This gives you a small template from the query processor. If you press this query table over here, they say to you to open the processor, they give you some scene already connected to that table, okay? Then if you say something like, what is the most 10 name for female created in the United States, for instance, from this stuff we just created, you get the result over there. So it's very easy to upload the stuff on BigQuery. Also, there is some stuff which I'm not going to mention a lot for you, but from the console itself, for the application, you can use a Google API as well to connect to your BigQuery and run everything from console. I think it's not going to worth it to talk about that right now because it's much easier to run everything from the editor itself than the console, which is command line. But if you want to use, you can do it, okay? I wanted to mention something for you as well. Let's say I got some query. Yeah, let me write some query. Okay, if I come into this query and they get some information about it, one of the information they give me the preview if you wanted to see what is there, But they also giving me some information about the data table, like how many rows there is, number of rows, everything. If you come to here and you query this to check how many rows in database as an SQL, you can do this by this simple query, say counting star. You see, you don't pay anything for it because it's part of the query metadata. They all give you this information for free. So this kind of a query doesn't charge you anything about it. So it doesn't matter if you do this from here, going to give you this total of a number, or if you just come to the data set itself and from the detail you get the number, which is that same. So far so good, people?
Yep, very good.
Okay. The other thing I wanted to show up, of course, I got the count itself, but let's say I wanted to count how many gender there is on this data set. The very good way to do it is to use it, count it with the syntax distinct inside of the count. Instead of the star itself, I can now count how many distinct gender there is on the query itself, which of course is going to show me 2. Okay, so there is quite a few syntax, and as you can see, everything is very similar to SQL itself, traditional standard SQL, but there is some small discrepancy, which is SQL for BigQuery itself. Let's say with distinct is very good, because if you say on this name is how many gender there is, how many year there is, how many state, how many different names there is, you can use this distinct stuff in this way instead of a group by, and you can get all this information in a very, very simple way. There. And you see there is 2 distinct gender. You have 104 different years. You got 51 states, 29,828 different names. And of course, I just compare here, either you can count star or count one of the field without the distinct, you get the same result, which is the total number of the rows. We query everything very similar to the standard SQL, where you can use something like where, of course, this is very standard one. Select it from the source where, like state like that, and gender, and the year, and the order by. This is very standard, similar data set, and you get everything over there. You can, of course, see when you work with the where, of course, you can compare, you can put the equal to, less than, greater than. Of course, you also can alias this stuff as a normal standard SQL demands. So you can run anything over there. And as you can see, most often the query itself, it takes not too small data, but it's very fast itself. And you consider with all the data is encrypted and decrypted, the result is amazing fast. Of course, you can do something like less than. This is very standard stuff. Is not something so BigQuery itself is more SQL itself, but that is a good and the amazing tool, in my opinion, because when you work with big data, we always do some program to extract the data, and if you can just extract the data in a large amount of data, just doing SQL is kind of amazing. Also, you can do some dynamic calculation field, like if you say how many bikes is running in a day, for instance, you can just say 24 hours times 60 hours, 24 hours by 60 minutes by 60 seconds, and you can instead of pass the total number, you can just calculate it by formula, and it's fine as well. You can also use stuff like how many bikes done some trip between certain hours. Again, you can use this kind of calculation dynamically between. I just forgot the 60 here. This is very good stuff. And of course, they do for you between this time in question. But when you start to use something like between, and, of course, it's much easier to use it in, which is very standard as well to SQL, where you can use it like here, where situation in 60 and 120 seconds, you want to see a very small heights, and there is 20,583 holes in that. I think this is very good to replace stuff like when you do something like, as I just mentioned here, when you stuff like or, you can just replace all this query for something more like in, and you'll be the same result and much easier to write. And all the time, if you're looking for the bottom of the my query, the left side, they show some small pop-up. That is the temporary table they created for the query itself. That means the second time I run, if I run like now, this time is they use the same table itself. The table is not charging anything for that. Also, of course, you have the opposite. Like say, you can say in or you can say not in. If you wanted to reverse the stuff itself. This is very pretty similar, of course, very fast result itself. And also you can, of course, query this inside the string if you like to, it's no problem, and the data type itself. And when you call stuff by string, you have to be very careful about, like a relational database is a case sensitive. Like if you put a small h instead of the harassment, you'll be not found, just like that. So be careful when you run a query on strings. The best thing to do, you can like convert it to lowercase. For instance, I'm going to run something like that. But also you can use regex inside of the queries and say like wildcard. I'm not sure. That's it. So and again, just find the where minor category has something like drugs, doesn't matter where, and you find some stuff. And of course, if I wanted to show this on the last word, I can just take off this stuff, and you see something like. For instance, they appear in the last word. Similar, as I said before, you can check for something anywhere on the field, but also is a good task sometimes to lower, which is a very handy function to query when you run something in string, because you never know which format the string are. Sometimes they be upstring, low string, or mixed cases. So when you run something, it's much easier to do some stuff like that. This so far is very similar to any relational database that people all create. It's not very different itself. What is very good here when you I think when you start to work with BigQuery, first to understand the timestamp itself. It's not that different as well, but it's very nice to know how time works on BigQuery. And I have some example here that I want to talk about.
One thing before,
yes.
We have some questions.
Yes.
Quick ones. Can we have an example of how BigQuery queries semi-structured and unstructured data?
Yes, if you leave a little bit more I'm going to show this later on.
Okay.
Yeah.
And what's the difference between BigQuery and Amazon Redshift?
Is a little bit different because Amazon Redshift is based on Postgre database with the serialized Postgre database. And SSH BigQuery is not on Amazon, on Postgre or any database underneath. It's just their own application with these policies and the stream itself. It works in similar way, but the Redcliffe is based on Postgre itself, PostgreSQL.
Okay, nice.
Okay.
And how can we scale BigQuery?
That is a good thing. You don't need to do anything. Even if you run some query itself, which you run for, let's say, 10 rows, and your BigQuery get it to terabyte, you just use the same stuff. And all this stuff itself is run automatically for you. So they Google scale this for you automatically. As more you start to put the data inside of the data set, more they run more machines for run this stuff to you.
Okay, and last one.
It's nothing which is not under your control. You don't control the size of the data set, things like that, like how many machines you're going to have, how many storage. Or, on the other hand, if you have a storage itself and you store your data on your storage, you can also integrate with the BigQuery.
Okay, and can it be scaled with Kubernetes?
Not really. I never used this together with Elasticsearch or whatever. I use this, but not on here, on the editor. It's a little bit more complicated. I think it goes a little bit out of the scope of this presentation itself. But if you wanted to integrate with a different data sets itself, is much easier to do this by programming language. Like, let's say you bind something pandas in Python, for instance, and then you do the transaction on pandas or something like that.
Okay, so let's move
on. Otherwise, you have to pay for third-party people, a company who does this kind of stuff. Of course, they got some integration with Elasticsearch or something like that, but it's third-party, you have to pay. It's not coming for free or easy to connect. In my opinion, it's much easier to connect this by programming language. Okay, I do this by Python, so some people can do this in different languages like Java or whatever. Okay? Is that okay? Or can I move on?
Yeah, we can move on.
Okay. When they come into here is something which I like a lot, and I'm going to give you some nice presentation based on this stuff. Data time is very important because we all the time need to relate some stuff, different tables with different time. And as you can see, I got the first field here, which is original one. It is declared as a timestamp, and then you see the timestamp with the hours, day, hours, and the zone, all that. The first thing you can do, you can always cast this field itself as a date. And the second one here, you see, start the time date, is just a cast the first one as a date. Automatically, they extract for you only the date time and they drop the hour itself for the cast itself. And after that, you can, if you wanted to get anything inside of this data, you can use the extract, however you like. I wanted to extract the hours from that field, and then of course you can alias to however like to. So you can extract the hours, you can extract the minutes, day, year, month, week, however. So this is very good. Very good function to know about it, because all the time you deal with stuff on analytical, probably you using time, not all the time it can be standard from databases. Of course, if you operate on time, you can also very useful to use something like you can cast data to make sure you're going to pass only the data you're looking to. It's very easy where you can only cast some data to as a, if you don't want to pass the whole data itself when you are exactly like where data is equal to. If you put the greater than, less than, you can just put the data and it will straight to the timestamp. But in that case here, you can be very strict to get only data for this exact day.
I have one question.
Yep.
How to create index? I mean, is this...
Great question, great question.
Okay.
You cannot. That is one thing that differs a lot from relational. And as I said, this is not a tool to replace a relational database. As the way they get the data, extracted the data from the data set, there is no way to BigQuery to create indexes.
Okay, nice.
So how it's possible it's so fast?
Google doesn't show anybody the secret. This is one of the very secret Google has.
Yeah, there's background
over there. Yeah. They said this two project, which is based on the stack for this one, IDA Colossus and the Dremel, is very secret. You don't find anything, no white paper, nothing. It's very secret stuff. Colossus is a more advanced Google storage file, and the Dremel is where you extract this stuff without the physical takeaway from the database. They extract this, stream this data, and they don't tell how they implemented it. But it is very fast. That is the amazing thing you can do on this tool. Okay.
Okay,
of course. Okay. Of course, you can also select the data between. As I said, you can. In that case, here you don't need to cast for exactly that day because automatically they know it's between this time. So it's not a big deal to cast this stuff. But of course, you can also use the in if you like it too. No problem. Like select something where data, like here hours, for instance, I wanted to extract only what happened on Hive on 17, 18, 19, 20 hours. So you need to extract it. That is very useful, and as you see, only between this hour itself. So it's very powerful and extract, and you see how fast this work is amazing. That's why I doing this as a demo, live demo, not as a slide, because I'll be able to run all the query in the show and the real time the answer to you guys. Of course, you got as usual something like now. When you look for something which is now or not now, you can say if you compare any field, if you got some now in there or the opposite way, not now. This is very standard as well, but yeah, you can also handle this kind of mechanism. And of course, you can start aggregate stuff. Like if you wanted to group some stuff, you can use the group by in a very pretty standard way. Like you see how many names you got from United K, which name is greater than, let's say, 5,000 people got this name so. And if you wanted to see which name is the opposite, not the popular one, you can see exactly the ascending order, and you see the most not popular names from this amount is networks. So you can group by, no problem. You can group by and having, which is very similar. And of course you can, this is just very standard stuff. Another group by is just very pretty. My train field doesn't matter. This is not a secret to any SQL developers. I can group by gender, by name, and also you can group by and uses some predefinition function, which, for instance, averages some max. So you can put it all together and you get results like how many. This is very good analytical query. We can give you all the trips, how many trips, grouped by the way they are being paid, like by caching, by credit card, by payday, however. And you can group by or divide, so you can see as well some internal function like sum, average, maximum, minimum.
Okay, maybe short, a few questions, okay?
Yes, sure.
Okay, the first one. What limitation would make you choose Hadoop or Spark or as your main project tool instead of the BigQuery solution?
Can you repeat it for me, please?
I believe that the question is about the limitation. Is there any limits?
No. If you come today to the field of big data, this is another subject to be discussed. What big data is? Because for some people, big data can be something which is considered substantial, and for the other company, this is nothing. It's much more bigger. But when you come to the field of big data, all these applications nowadays which you run with, like from Kafka, BigQueries, all the Apache ecosystem, Hadoops, and all the related stuff to that, Hive, all this stuff is being developed to handle massive amount of data, petabytes, however. So it's very difficult to answer this question because, as far as I know, there's no limitation at all nowadays.
Okay. So, Gilson, are you painting the green grass on the more green? Because really, it sounds like unicorn. There is no limitation.
Yeah, let me. What all this stuff is being developed, like if you look for the Apache ecosystem, everything which is there, if you work with the Kafka, all this stuff, there's no kind of a limitation anymore. They just stream how much data you can be streaming and just pass through. That is the idea of this stuff. Like a BigQuery, there's no limitation at all. And they scale so well, You're just going to pay more. But if you wanted to work with a terabyte or even petabyte, it's just up to you. That's why Google makes some money. How much more you put the data there to query, much more you're going to pay.
Okay, next question is short. Is it possible to execute queries from console or alone from the...
Yes. Yeah, you can. If you use it to console, you can query everything you've done here, you can do by console. The same way when you done any connection to normal regular database like Postgre or MySQL, you do the console as well. You can do from the console here. Also, you can install the client, the Google platform BigQuery client in the language you prefer. And you also can do this by programming language, like can do query by Python, by Java, or whatever.
Okay, and the next question is it possible to have here some kind of UDF? I believe it's user-defined function in the query.
Yes, it is. There is some limitation in BigQuery when you use like views. For instance, if you use views, they limit you for 1,000 views maximum per data set. But in views, you cannot create a defined function. But for the normal table, yes, it is possible.
Okay, and the last one this time, what about geographic or spatial data supported by BigQuery? What data types are you supported by BigQuery?
Graphic. They want to show graph, they say? Yeah, I'm planning to do something at the end of this presentation with the database. You can export it to any graphical interface like to Cricut, Tableau. I'm going to use Data Studio. I like it to integrate it to Data Studio. It is very useful. And it's if you wanted to see straight ahead on Data Studio, if you can see here, explore data, you see my button over here in the middle of my screen?
Yep.
If you click there, you can just export it to Data Studio. and it automatically will be shown for you. See? Then you can change however it suits you.
It's like Tableau or Power BI?
Yeah.
Yes, it is.
Okay. So the question exactly was about the different place, I mean geographical, not the graphs.
Geographical.
Yeah.
About. Oh, sorry about that.
Yeah,
yes,
no.
when do you create your project itself on Google, you have to select your regional area for this. And it's something you cannot change after you create a project on Google. You cannot just change your regional settings. And when you run any query on big data or however, because this is sitting in the same project, they put all the storage on the same regional setting from your project.
Okay, so
it's not you do this by BigQuery, like I'm going to select this table and going to set in this regional setting. It's going to be like the project settings where your project is sitting down.
Okay, thank you. So let's move forward, okay?
Okay. Carry on like that. I just let's say if I wanted to analyze it from these queries, let's say how is the most payment method for bike riders in New York? You could say where type in cash or credit card, and you can see the same group by queries. No problem at all, of course. And you will be running very soon, and only for these two types. See, you got this amount of for cash and for credit card, things like that. It's very, the amazing stuff with it for me is so nice. It's like I needed to do some analytical function for my company. I just can do this by SQL. It's so handy to get all these handy, you know, like instead of all the whole program itself, how can I extract the amazing analytical stuff in a very large amount of data just in doing SQL? That is amazing for me. And of course, you can run all kinds of stuff like having, of course, it's very standard way for people who know a little bit of SQL. It's very easy to follow. And of course, you can see like how much payment was done on trip which is more than 300,000. And of course, as a normal stuff for all the relational database, you can also join tables, of course. You can just join with some left join, right join, inner join. They have all kinds of join they supported. And you can just join tables. And the amazing join is a little bit slower, but not that slower. You can join a lot of tables in very fast time as well. Sometimes you can use it like a predefined question function, which show already, but some of that, like use a trim, then lower, so you can mix up all this stuff to make it very desirable queries. You can use this function also with let's say with the joins. You can join and then use these all predefined functions like I join, then I use a trim, I group by or by, so you can, it's very, very powerful, and you got basically almost all a SQL syntax to query everything in your big data. Let's see. Let's do something very heavy to see how fast you'll be. That is for some kind of no, this is not a very fast one. Big one. Okay, what one more bigger than that. This is just you can have so many joins you like to as well. You can join so many different tables, and when you run things like that, you see it's quite fast for the amount of tables you are running through. The one good stuff which I found on BigQuery is very handy is the syntax of accept. sometimes when you have it, because it's a column I/O, not a whole I/O. Sometimes it makes a lot of difference how many columns you're going to select to structure data. And depending on the size of your columns itself, the amount of columns you have in your table, sometimes it's the opposite. Instead of listing all the tables, the columns I want to choose, I can accept the one I don't want to choose. Like, let's say if I want to create something like that. Let's say this up first. Here. Let's say this is the whole table, the column itself. And if you come here, you see I got a removal date in the last column. I don't want that column. So instead of listing everything, I can just use except that column. I can run everything, but not that one. If you run that column, they remove that for me. And if, of course, you can pass how many columns you don't want to. Let's say temporary. Also, you can press Control and the Tab, and you see the column itself with the pretend belonging to that table. So when you select stuff like that, you have two options. Either list all the columns you wanted to select it, or if in the opposite way, you can remove it, the one you don't like it. I think this is very handy for syntax itself for this kind of a proposal.
We have one question about geospatial data. I will unmute Evelina.
So special data?
Yes, my question is store geospatial data in BigQuery. So for example, I know that in Snowflake we can have special data types like point, polygons, and etc. for geographic data.
Yes.
I'm wondering if it is something similar here.
I'm not so sure about that, Kubernetes, because I never used something like that. I'm pretty sure you'll find something which can be used, but to be honest to you, I never use it. If I say something to you, I'm going to be guessing it. That's not good stuff. So I cannot answer this question for you, unfortunately.
Okay, I found somebody sent me an documentation, and I found that here it also supports geographic data types. So this is similar to Snowflake.
Okay, that's good. Good to know that. Thank you.
Okay, so let's move on.
Yeah, the other thing you can do, of course, as you can see here, they keep a history for you for all the data you have done on the editor. Like say, if you go to query history, they list for you all the query you can run. And of course, if you click one of that queries itself, and then you just say open editor, they replace it for you the query itself over there. And you also, if you want to run constantly the same query, you can save the query itself. Which after you save the query, you come from here and say save the query. And you can be only for you or for everyone listed in your project. It's up to you. And once you save the query, you can run in the same way here. You just need to come from save the queries. I don't have anyone here, but either personal queries or project queries will be this similar to job history or query history. Okay, it's very handful stuff you can do as well. One more thing I'd like to mention to you is you can also query something like based on internal function, like let's query everything where ling is where I think I don't have it. Okay, I don't have this London database, I believe so anymore. Let me see about it. Let's say for the very public one, check that there is you can also type something like London here, and you see some station over here, and now I can do somewhere over there. Open, selecting. Flow. That's okay. And you can see like where language, for instance, in name is bigger than 8. Or it can be bigger than something like 2. So any of these column, it can only be like bigger than 40 character length, or let's say 20 or however like 2. The other very good stuff for analytics, Google has some very predefined function which helps a lot for analytic stuff. Like they got a variation, standard deviation, which you can use as well. Something like var pop is variance and the standard deviation there, so you can use this analytical function. There's a lot more. Of course, all this stuff can be found on Google Types, Google internal functions, things like that. You got a list of all the analytical functions. But just to mention, there's quite a few over there for you. Of course, you can support stuff like if, for instance, if the name appears like a Hackner, you're going to say true. If it's not, you're going to say false. And you can have a multiple if, not a problem. If something is don't count bigger than 40 is large, so it appears this stuff for you there where you created this field on the fly. And of course, you also have a case statement.
I have one question.
Yes.
Is it possible to connect BigQuery to some in real-time data processing, or maybe something like Hadoop or Kafka into BigQuery reports or something like that?
No, from you can do this all by program, because if you wanted to create it for Google, you have your project has to be open on Bigtable to use Hadoop, all this stuff. And between Bigtable and the BigQuery cannot connect itself. But you can do this. You can do this extremely by code. That's why I said we're about to use a lot of third party. I think it's very useful when you install like your Google Cloud platform client, everything for Google Cloud in your computer. Then you can unlimit a lot of stuff.
Okay, nice.
Okay, so in this case as well, instead you create something like if the doc count is less than small, blah, 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 so you can use the select cases. And you can, I want you to do something more. This is something I want to talk later on a bit more stuff. That is one of the queries. We can cast time in the format I like to choose. That's why data time is so good. I'm going to talk more about that. I'm going to do some practical example. But this is one of the queries that I enjoy, like say, to give me one report on product name, customer, very easy customer connection data tables. But I draw your attention because this query is almost 300 gigabytes. If you see my green stuff over there, the process itself is going to take 290.4 gigabyte. Let's see, and even so, extract the stuff and concatenate the stuff, everything. Let's see how long it is, and also filter some data and where some field is not. Now there's quite a few passing through here. Let's see how long it is taking to be run. There's quite a lot join. See, there's field join, there is a filter, there is a parse stuff. So it's quite a heavy query. If you run this in the normal data sets with almost 300 gigabytes, you'll probably take quite an amazing long time to run this. So it takes me about 25 seconds to run this. I believe so. I tried to run something similar on Postgre once and it took me about 20 minutes or so.
Is this possible to see plan of the query? Something like explain analyze in Postgres or something similar?
Yes, I'll go to do that.
Okay.
Okay, I'm almost there already. Okay, so I just showed this. This is very standard query. Company has like the data, the product or sell with the customer, blah, blah, blah. And just to show like a lot of join, a lot of the query itself, and it's very large. That is the most large query I'm going to give in my example. Even so, a query large as that is possible to do a live demonstration. See how fast it is to do this. Where it is nice to use this parse itself for casting data. That's why I wanted to give a little attention. Let's say, for instance, let's suppose you wanted to query something like give me the flight number from certain airport and the delay time for that flights. Let's say I got this database over here. It is giving me something like I got this the airport name and how many delays they have on certain airport. In that case, the Guardian Airport in New York. If you okay, now I'm going to do one other query, which is filter by a particular date. The same query, but I wanted to filter for some special date. It's something that come a lot of like what happened this day, blah, blah, blah. And also, I wanted to show up one thing with much easier. I can combine both the number of fly and also the number of delay. It's not difficult to do that, of course. And we're going to show something what this function is all good to. I got the number of fly and the number of delay. You can see there's quite a lot of delays based on some flies. Let's say if you are developing some analytical stuff, you could say something like maybe the reason why this is happening because maybe in that day it's raining. So you have it to, let's say you wanted to research, do some query in the completely different sets. It's another table which might show you in New York where this airport is sits, and you query by now from the rainy days. And as you see here on this query, you got the year, the month, and the day on separate stuff. Could it be an integer? Could it be a string like an integer itself? But it is not on a standard day, which is like year, month, and day altogether. So what you can do is, I can first transform that to join these two tables together and see if the rain is the reason why you got a delay. So that's why this function is very nice. You can concat, you can cast that year as a string, and then concat it to if. You can have to pad the number with the 2 decimal, fill up the zeros, and it's very similar stuff. And you can see the result will be all converted to a normal date itself. And of course, now from there, we could say, something like a, let's put these two queries together, where this function comes very handy now is here in the line 4. I could join this now between these two, and you can say very clear the days which is raining, which is the total population bigger than 0, is happening a lot of delays. So it's a kind of a real stuff. And of course, you can also calculate more fields if you like to, like you can say the same query and say like, I want to choose, say, some average as well. As you can see, you can start modeling your big data for answer what you like to do. So I combine these two. Now I know the number of fly for that report to the company, the number of delays, the total number of fly for that company, and also I've done some average here to see the fraction that represents. This is very handy way to cast this kind of function data, or something like that, where almost all the time it coming from different tables and you need to combine the data together. Of course, you can use the head X if you like it too as well, something like let's create something with the regex contain title, and inside the title a little bit more refined query. It needs to be something with appear with these letters or something like that. It's very supportive as well. And you can get all these, extract all this information from big data. Now, I like to call your attention for something very nice. You can, as I said to you, BigQuery is a schema, strictly schema dependent. If so, they keep all information metadata. It's not a Hive, but they have their own metadata, which they keep all the information about that. So you can say, like, you can query all your metadata itself on BigQuery. The good thing is you never charge anything to do that. For instance, here I could say, if you see if I write stuff here, I could say on this data set which I run, I got 3 tables, and also the size of the tables, the number for the whole, and I could comparison in case it's exactamente, if you type is 1 is a table, if it's like 2 is a view, and it never charge you a penny for that. You can see my process is 0. And you can do a lot of good stuff on that. For instance, let's say what is the 10 most tables which contain most rows in my data set. You can do some statistical stuff based on database, on metadata like that. And they say that is from my data set itself, that is data set, and the most number of rows in each of these 10 big selection for this select, let me see. But it is possible to analyze, make analytical inside of metadata. And however you do that, as I said, you never pay a penny for it. Of course, they got something we are not going to mention out here, but there are some Windows functions, which is like ranking, which is this kind of stuff, which you, of course you can rank stuff as well, one partition, all this stuff. I'll leave this for something a little bit more second stage of a BigQuery, let's say. But you can rank words, stuff like that, based on function of partition, and it also works so fast as well on BigQuery. The one thing I wanted to talk now is something which is not so frequently people who work with BigQuery talk about, and in my opinion, is one of the most important things. Because if you are doing some warehouse, you might need to do some project which involve more than one data set and change information between that. BigQuery change information with the crowd SQL, not with all database itself. If you wanted to change information between a different database which is not on the crowd SQL, you have to do this by program. But if you got a SQL database on another project with inside the Crowd SQL, and you can have only MySQL or Postgre, you can get the information about your project. It's very easy. Just go to your project itself and get information there. And you can come here and add external data for that. When you add external data, you come with this format to be filled. You can select if you are going to query MySQL or Postgre. You select what your data is. And you can give any name for the connection you wanted to call that. You have to set this query, the region you like to. This tool not Excel is optional, you don't need to put it, but you need to create your project ID and your data set if you are not to query, your username and your password. And when you've done that, and you say create a connection, your connection will be created under your project name. Something happened here. Yeah, you create here and you see your connection, external connection here, okay? And this is my project ID. You see here my instance. I got a database set there, and it is Postgres. And I got now, you can imagine you got now a pointer to another database. Now you can interact BigQuery with this external data. And do I like to change data from one to the other, join, however you look, you done it so. Everything with you related to your Crowd SQL is not charge you anything about it from the Crowd SQL because you pay for storage. But when you relate this with the BigQuery itself, you have to pay for something about the SQL part and the BigQuery part of it. So let's say after doing this connection, if you say something like here, select everything from my external query. They know this connection name, usme.com. And from there, I want to see all the regions in that table. That table is in my Postgre, not inside of my BigQuery project. If you see my right side is 0 process part. So it doesn't charge for me because I said I pay for Google Cloud for having this Crowd SQL and that is charged by the storage. So when you run something you pay by the storage, you don't pay here. And this data coming from my Postgre database, not from BigQuery itself. And say so, you possible, of course, you can interact with both. Let's say I got this database in here on this data set, it's called department. So I got all the stuff under the table, it's called employee. So I can now get my external employee. When you use this area, it looks like this kind of external data, very similar to who program C language. It's a kind of pointer. They bind this query itself, this inner query, inside this variable. And now from that variable, which is similar to alias, I can interact with the whole BigQuery itself. So I'm selecting something from EX, which is coming from my external data, and then I'm going to join this with the department on my department here, and where department is moved. So some part coming from BigQuery, and some part coming from my Postgre itself. So you can join, and this very way you can work with everything as they are interconnected. And I think this is one of the more powerful and the, let's say something much more complex. Let's say that's where most people need to work when you create some kind of a data warehouse, when you got so many different data sets to interact. Okay, now I can connect and see, I select this from department to county, that from external I pick up the employees, and department is my BigQuery itself. This is something, in my opinion, one of the most important stuff to learn about. I don't have many time, but I wish to show something more graphical now. If people, I don't know how many questions people got.
Okay, Gilson, so
yes.
Let's do that in this way. Let me show just the last slide. We finish recording, and then we have like 25 minutes or 20 before.
I wanted to show something more practical.
And then it will be open session to everyone can ask you because, okay?
Yeah, sure.
Okay, so like the screen sharing. Okay, I will share my one. Where is my one? Here. So yeah, where is it? Okay, so here's the slide with the email, private email to Gilson. If you have any questions, you can send drop him an email and ask any help. And Gilson told me that he will help you as much as he can. So thank you for joining to us. And we finish recording, and then we can start the, let's say, unofficial, and I give you, unmute all of you, and you can ask the questions, okay?